Right, in this lesson we are going to be talking about finding inverses, and we're going to be finding inverses of exponential equations and equations that either have log or ln in them. One thing that we need to remember from the earlier lessons is we talked about the fact that exponentials and let me try writing that again. Exponential form and logarithmic form were inverses of each other. Okay. Now, in case you don't remember those, let's go ahead and write down what those forms were. So exponential form is y equals b raised to the x. And the logarithmic form is log base b of y equals x. All right, first thing we have to remember about inverses when we're starting out the question is that you start by switching the letters x and y. So on problem number 1, I'm going to switch this and make it x equals all right, sorry about that. As we were talking about on the first one, you want to start by switching x and y. So we would start off by saying x equals log base 5 of y. Now, the only way to get the letter y by itself, to get rid of that log on the right side, is to take it from log form and rewrite it into exponential form. Okay, so exponential form starts out with y equals, and remember at log form, y is the big thing after log. So then here I would say y equals base. What's your base for log? And that is the number 5. And then raised to the x. And x is all by itself on the equal sign, which is also our letter x. And then y is by itself, so you don't have to do anything else to solve for y. The last thing you have to do is just put in your inverse notation. So y to the negative first, remember anything to the negative first is inverse notation, equals 5 raised to the x. So you'll notice how the problem started in log form and then we ended it in exponential. Because remember, exponential and logarithmics are inverses, are opposite of each other. Okay, next one. Start by switching x and y. So x equals 8 raised to the y. And this one you're going to notice is in exponential form, so you want to rewrite it into the log form. So we're going to start out with log base b is the one that has the exponent attached to it, so that's my number 8. Y is all by itself on the equal sign, which is our letter x, equals x, which x happens to be your power, and our power is y. And then you're going to notice y is by itself, so we are done. So the inverse equals log base 8 of x. And once again, you're going to notice that this problem started in one form, which was exponential, and ended in the other form, which is logarithmic. Number 3, start by switching x and y. So we're going to have x equals ln of y. And then ln is technically still the log form, even though it doesn't have log, it has ln. And so our job is to write it into exponential form. So for exponential form, y is going to be the part after ln. So that's our y. The base for ln is always the letter e. raised to the x. And then y is by itself, so I'm just going to put in my inverse notation, and the answer is e raised to the x. Okay, let's look at 4. Start by switching x and y. So x equals ln parentheses y minus 4. Now the y minus 4 is in the parentheses, so that means it's grouped together. So don't try to add the 4 over right now. We're not allowed to do that because it's grouped in the parentheses. The only way to make the parentheses go away is when you rewrite it in the other form. So let's go into exponential form. So y is the part after ln, which is going to be our y minus 4, equals base for ln, which is always the letter e, raised to the x. Now you're going to notice that y isn't by itself. We have to get rid of that minus 4. So in order to get rid of the minus 4, you need to add it over. So now I'm just going to put in my inverse notation. So the inverse is equal to e raised to the x plus 4. Okay, 5. Start by switching x and y. So x equals log base 4 of y over 3. Okay, so let's rewrite it into exponential form. So if I rewrite it, y is y over 3 equals the base, which is 4 raised to the x. Now, if I want to get y by itself, to get rid of a dividing by 3, we have to multiply by 3. So then I get y equals 4 raised to the x times 3. It doesn't matter which way you write it. I've seen some companies for textbooks that write it 4 raised to the x times 3, and then I've seen some that write it backwards where they put the plain number first and then they put the one with the exponent second. So either way is acceptable. It really doesn't matter. I'll put my inverse notation up here. So you can write it with the exponent part first, or you can write it with the plain number first. Okay, so hopefully you're getting to be a little bit more comfortable with these, because the last 5, they're going to get harder and harder as we go in, because we're going to throw in some more and more steps. Okay. So if we look at 6, once again, we're going to start by switching x and y. So x equals log base 2 of 8 over y. Then we're going to rewrite it into exponential form. So 8y equals 2 raised to the x. Then to get rid of the 8 in front of the y, we're going to divide. But here's where the tricky part comes in. On the bottom, I'm not going to just leave it as 8. I'm going to think, what can I make my base numbers the same? So on top, it's 2 raised to the x. So I want to think on the bottom, can I go 2 raised to a number that will give me 8? And yes, you can. You would say, oh, that is 2 to the 3rd power, because 2 to the 3rd power is 8. And then you're going to remember your exponent rules that say, ooh, if I have the same base, which I do on top and bottom, they're both 2s, and I am dividing, what do I do with my exponents? And hopefully you remember and say, ooh, subtraction. So then you're looking at the inverse for this problem being 2 raised to the x minus 3. So that one was a little tricky because we had to work on making the bases the same. Now, you won't always be able to do that, but anytime you can, you must. Okay, 7. Start by switching x and y. So x equals log base 4 of 6y plus 1 minus 2. Now, before I rewrite this one, you should notice that that minus 2 is not in the parentheses. So that means I want to get rid of it. So to get rid of it, I'm going to add it over. So x plus 2 equals log base 4 of 6y plus 1. Now I can rewrite this one into exponential form. So 6y plus 1 equals base, which is 4, raised to the x plus 2. Now my job is just to get y by itself. So to get rid of the plus 1, we're going to subtract it. So put minus 1 on the other side. And then to get rid of the 6 in front of the y, we're going to divide it. So my inverse answer is 4 raised to the x plus 2 minus 1 all over 6. Okay, next one. I'm going to switch x and y. So x equals 4 raised to the 3y plus 7 plus 9. Now, you're going to notice that that plus 9 is not up as a power, so we can go ahead and move that over. So I have to subtract it. So x minus 9 equals 4 raised to the 3y plus 7. Now, this time we are in log or exponential form, so we're going to rewrite this one into log form. So log, and then my base would be 4. And then y is x minus 9. And I'm going to put that in parentheses so I keep that group together because that was all on one side. And then we're going to have equals x, which is 3y plus 7. Now my job is just to get y by itself. So I'm going to subtract the 7 over. So you're going to have minus 7 over there. Now, please do not try to combine the minus 9 and the minus 7. We are not allowed to do that because the minus 9 is grouped there with the x and the minus 7 is not. And then the last thing, to get rid of the 3 in front of the y, we're just going to divide it away. So my inverse is log base 4, inside my parentheses, x minus 9, then minus 7, all over 3. Okay, number 9. So start by switching. So x equals 6 raised to the 2x plus 3 over 5. All of that is raised to the 1/4. And whoopsie, I wrote x over here on the right side, but I really didn't mean x. I really meant y because we were switching the sides. Okay, for this one, I want to get rid of that 1/4 power. To get rid of the 1/4 power, you want to multiply by the reciprocal. And the reciprocal is 4 over 1, or just 4. So you need to put a power of 4 on both sides, and then that will make this 1/4 go away. So you're looking at x raised to the 4th equals 6 raised to the 2y plus 3 over 5. Okay. Now we want to get rid of that over 5. And to get rid of the over 5, we're going to multiply both sides by 5. So we're looking at 5x to the 4th equals 6 raised to the 2y plus 3. Now that I finally have the part with the exponent all by itself, nothing, behind it or below it or anything like that, we can rewrite it. So this one is in exponential form, so let's rewrite it into log form. So log base is 6 of y, which would be 5x minus 4, and I'm going to put that in parentheses so it stays grouped together, equals x, which is 2y plus 3. Then we just want to get y by itself. So to get rid of the plus 3, I'm going to subtract it over. And then to get rid of the 2 in front, I'm going to divide it away. So my inverse answer is log base 6 of 5x to the 4th minus 3 all over 2. All right, one more. So for the last one, all right, we're going to start by switching. So x equals 3 log parentheses e raised to the 7x plus 2 minus 6, close my parentheses, plus y. And darn it, I did it again. Make that second x into the letter y. Okay, now, after I've switched x and y, I want to go about getting the log parentheses part by itself. So to get rid of the plus 5 at the end, I'm going to subtract it over. Then after I have subtracted that over, I want to get rid of the 3 in front. And to get rid of the 3 in front, you should divide it away. So divide by 3, divide by 3. Then once I have the log parentheses part all by itself, this is where I want to rewrite it into exponential form. Okay, so exponential form, y is the whole part after the in the parentheses. So e raised to the 7y plus 2 minus 6 equals base, and the base for log, if it's not listed, is 10. And then raised to the x, which is x minus 5 over 3. Now, from here, I'm trying to solve for y. And if I'm trying to solve for y, I'm going to notice, ooh, y is a power. Okay, the only way that I can take y out of the power is to put a ln on both sides. And I chose ln because it has the letter e in it. So if I put an ln on both sides, then I get to pull my exponent out in front. So I would have a 7y plus 2. Oh, hold on. Sorry. Back up. I skipped a step. We're going to do this step in just a second, but I just now happened to notice, whoopsie, e is not by itself. So if e is not by itself, I should get rid of that minus 6 first. So I'm going to do e raised to the 7y plus 2. Let's add the 6 over. So when I add the 6 over, I have plus 6. Now I notice that the e is by itself, and this is where I can do the ln on both sides. So pull your exponent out in front, ln of e equals, and then we're going to do ln of this 10 raised to the x minus 5 over 3 plus 6. On the left side, do you remember ln and e cancel each other out? Boom. And now I'm just trying to solve for y. So if I want to solve for y, I have to get rid of this plus 2. So I can get rid of the plus 2 by subtracting it. So 7y equals ln of 10 raised to the x minus 5 over 3 plus 6, and then minus 2. And then finally, the last thing I'm going to do is divide by 7. So my inverse answer would be ln 10 raised to the x minus 5 over 3 plus 6 outside the parentheses minus 2 all over 7. Yay!